Hi, this is Don Gettner with Ridge Engineering. In this tutorial, I'm going to show you the changes that were made to PC Warrants to support the changes to the 2009 MUTCD. Specifically in this tutorial, I'll show you the changes to the pedestrian warrant. In another tutorial, I'll show you the changes to the new warrant that was added, the rail crossing warrant. But this one is specifically for the pedestrian warrant. There were many changes to that warrant, and I'll show you how it now works. This tutorial is primarily for people that have already used PC Warrants and is familiar with the operation. If you're new, I think you'll still get a pretty good overview of how the software works, but you may want to look at one of the other tutorials that gives a more general overview of the software. I'm going to start right in by retrieving an existing file. And I'm going to pick one that I've already selected for the pedestrian warrant. And first I'm going to show the changes to the volume data screen. One of the major changes to the pedestrian warrant is that now we need to support 15-minute pedestrian volumes. You may remember in the older warrants we only had to support hourly pedestrian volumes. And on the volume data screen there used to be a separate window over on the left-hand side just for the pedestrian volumes. Now that frame is gone and it's replaced with an extension of the vehicle data, since they both work on the same time frames. So there's now 4 new columns for the pedestrians crossing the 4 lanes, and they work the same way as the other volume matrix used to work. So you can scroll down and edit individual 15-minute periods now, and you get the hourly summaries. And you can see that there are some obviously fake numbers that were added to this study just to show how the warrants work. You can still do the same things that you normally used to do with the volume data. You can shrink it so you just see the hourly summaries. That's a good way to just make sure you've got enough data in there. And I'm not going to spend much time on this screen. So presumably we have the pedestrian volume somehow. The best way is probably going to be to use the JMAR turning movement board and to count pedestrians while you're doing the turning movements. If you do that, then you can import not only the vehicle counts but also the pedestrian counts without having to type in any numbers. If you don't do it that way, then you'll have to edit the pedestrian volumes by hand. We'll click OK and go back to the main screen. And now I'm going to look at the site data screen. There really isn't that much of a change for the pedestrian warrant. Actually, a couple of the requirements have been eliminated. It used to be that gaps were an important part of the pedestrian warrant. They've been removed probably because nobody ever actually collected the gap data, and it made the pedestrian warrant almost impossible to use. And also, there's no mention of medians in the new pedestrian warrant. So the idea of storage for pedestrians in the middle of the street has been eliminated. So there's the one parameter that is still active is the pedestrian speed less than 3.5 feet per second. And this is a fairly critical setting. So you have to be a little bit careful about setting this. Now, the pedestrian speed is actually the 15th percentile speed. So I guess in theory you would have to go out there and measure the speed of 100 pedestrians and figure the 15th percentile speed. I'm not sure anybody's actually ever going to do that, but probably what you'll do is say, okay, this intersection is near a nursing home where there's a lot of old people, or it's near a school where there's a lot of young kids, and the pedestrians there are not able to cross the street at the same speed as at other intersections. And so you'll set this setting to say that this is a low pedestrian speed intersection. But be careful, I'll show you exactly how much that comes into play in a minute. Also, the built-up community and the adjacent coordinated signals are active in the pedestrian warrant, just like they are in several of the other warrants. And the closest signal on the major approaches is an important number. If it's less than 300 feet, then the warrant is not going to be met. If it's greater than 300 feet, then that's okay. So these numbers tend to be important as well. Now I'm going to show the pedestrian volume detail screen, which really shows all the calculations that are done to see whether this warrant is met or not. The screen looks a little different because they really have changed the fundamentals of the pedestrian warrant. It used to be that there were fixed criteria for the number of pedestrians and the number of vehicles and whether or not the warrant was met. Now they're using some of their curves that they like to use. And this curve is of the major street, the total of both approaches of vehicles versus the total pedestrians. So if you think about the other curves that are in the warrants, they're the major street vehicles versus the minor street vehicles. So this is different. It's the major street vehicles versus the pedestrians. But the idea is still the same. You find the major street vehicle total, you find the pedestrian total for a particular interval, you plot that point on this graph, and you see whether or not the point is above or below the curve. If it's above the curve, the warrant is met for that hour, and if it's below, it isn't. Now there are several different curves that come into play depending on settings that you have up here. One of them is if you use the rural settings, the 70% factor, you can see that the curve drops down, making it easier to meet the warrant. That's the basic idea. And also, if the pedestrian speed is less than 3.5 feet per second, if you determine that that's true for this particular intersection, and you check that, you can see that the curve drops dramatically. It actually drops by 50%. The warrant, the language in the warrant says that you can adjust the criteria by up to 50%. So the software at the moment starts at 50%, but there is a setting in the preferences screen if you want to change it to some other number like 30 or 40%. But it's a fairly significant adjustment, so you have to be a little bit careful about whether or not you check that. And there are two types of volume criteria. There's a 4-hour criteria where you need at least 4 hours of a given day to meet the warrant. And there's also a 1-hour criteria. Now that criteria is quite a bit higher, but you only have to meet it for 1 hour. So there's a 4-hour and a 1-hour criteria for, and if either of them are met, then the warrant can be met. Now what the software does is it takes the data that's in the volume data screen and it finds the major road totals for each hour for the 4-hour criteria, and it finds the pedestrian total from the pedestrian matrix that's on the volume data screen, and it plots the major total vehicles against the major total or the pedestrian total and sees whether or not that is above the line or not. And you can see that with the data that we have here, there's only 1 hour from 9 to 10 that meets the criteria. And you can see that a little bit better on the curve. You can see that there's only 1 point that meets the curve. If I change the criteria then and use the rural factor, then 3 hours meet. And we can see those 3 hours down here. Similar idea with the 1 hour criteria. In this case, when we drop that curve down because of the roll factor, there are 10 hours that actually meet the minimums. We only need one, but there are 10 different hours. Now I should explain that the hours for the 1 hour criteria are different. They can be any 4 consecutive 15-minute periods. The language of the warrant is very specific about this, and so only in this case can you use 8:15 to 9:15, for example, as an hour. It used to be there was a lot of discussion about whether or not you can use 8:15 to 9:15 anywhere in the signal warrants, but it's very clear from the way that they've chosen the wording that they only want you to do this type of 15-minute boundaries in 2 cases. One is here and one is on the peak hour warrant. So the software calculates every possible hour from midnight to midnight and then finds the vehicle total for that hour, finds the pedestrian total for that hour, and then checks to see if that point would be above the curve for the appropriate curve for this data set. And if it is, it puts yes over in this column. And so we can change that to, if we go back to the urban settings, there's none. And you can see that the software will sort the ones that meet the warrant. But you could also, if you want to, change the sort order by clicking on the total at the top of any column. And that might be useful at some point if you're trying to understand why certain hours meet or don't meet. So there's 2 criteria now, 4-hour criteria and 1-hour criteria. The 1-hour criteria uses 15-minute boundaries on the hours, but you only have to have 1 hour that meets. The 4-hour uses 1 hour boundaries, but you need 4 hours to meet the warrant. If you use the PC warrants, the rest of it is pretty much the same. You'll use this screen to verify that the data makes sense. The information here in the site data required is also duplicated on the site data screen, and typically you would have filled that out before you got to this screen, but it's useful to be able to check it here and make sure it all makes sense. Once you're happy with this screen, you click on OK. You'll go back and the software evaluates that warrant, and now we know that it's met. And if I want to, I can print the report. So that's the changes to the pedestrian warrant. There's actually quite a bit of code that had to be written. Thank you for watching this tutorial.